Hi everyone, I'm Ren. Our topic is smartphone review feature extraction. Our agenda are introduction, data description, problem statement, methodology, which include classification and LDA modeling, results and discussion, conclusion, and contributions. I will introduce introduction and the data description, then Zhongli will refer to the problem statement and the methodology of classification. Next, Chi will introduce methodology of top modeling, and last, Da will talk about LDA visualization and the conclusion. Now, let's begin our first part. The smartphone industry is important. There has $0.5 trillion industry and growing. In 2017, smartphone users expect to grow 200 million to a total 2.53 billion in 2018. In smartphone market, there are two main competitors, Samsung and iPhone. Apple and Samsung have devout customers that routinely purchase their products, and Apple and Samsung products are distinct in many features that tailor to their customer base. The dataset of Amazon smartphone reviews retrieved from Kaggle.com have 6 features, which are product name, brand name, price, rating, reviews, and review words. On the methodology of a classification part, we set a review words which greater or equal than 7 as 1 and less than 7 as 0. To get rid of some noise datasets such as phone cases, chargers, we set our price threshold to $199.99. For total reviews of dataset, we get about 63,100 reviews less than 7. 3,163 reviews greater than and equal 7. For Apple, we get about 31,200 reviews, which the price is greater than $199.99. For Samsung, the number of reviews which the price is greater than $199.99 are about 35,000. Then we use the cutoff value of 7 to separate Apple and Samsung dataset to helpful and not helpful. For the Apple dataset, we get about 29,400 not helpful reviews and 1,802 helpful reviews. For Samsung dataset, we get about 33,700 not helpful reviews and 1,361 helpful reviews. Then we visualized Apple and Samsung dataset to histogram graph. The graphs showed that Apple and Samsung dataset are highly skewed to the right. Looking at the descriptive statistics, there seem to be more words per Samsung reviews versus Apple reviews. Both the mean and median words per Samsung review are higher than Apple. Next, Zhongli will introduce the problem statement and the classification process.
Hello, I'm Johnny, and I'm here to talk about the problem statement. We devised two types of problem statements, one for supervised learning and another for unsupervised learning. Our supervised learning deals with our classification of reviews greater than or equal to 7 review votes. So we asked, can a smartphone review be predetermined, useful, and forced visibly to the front to encourage customer engagement? I'll be discussing about the classification models that we use and our metrics upcoming. The unsupervised portion is, are there important topics to Samsung customers that Apple can extract from Amazon reviews? Chi and Da will be talking about that in the LDA process and the tokenization of the text and our visualization to achieve the results for the second part for the unsupervised learning. Our process for identifying useful reviews involved 4 steps. The first step was our data collection, which we received from Kaggle.com. It involved Amazon reviews on smartphones from a variety of products, product names, and from that, our next step was isolating the specific products that we wanted by cleaning the data. So the next couple of slides, I will show how we clean the data, we fit it to different models, and evaluate it using a non-accuracy metric. As Ron discussed earlier, our filtered products were products less than $199. This limit was chosen to filter phone accessories such as cases and chargers, so we did not compare phone accessories to phone products. Additionally, we set a $199 threshold so we can compare similar Samsung phones to Apple phones. This is the code that we used to isolate the data we wanted. Next, we added a column to support our classification model called Review Good. The threshold review vote count was set to 7 or more, and this function was applied to every column. So if the review votes for that review is greater than or equal to 7, a 1 was inserted into the column, and a 0 if it was not true. Last, we identified the not a number values in both the Apple and Samsung subset and realized they were small enough to discard. So 2 from Apple and 12 from Samsung. The next action we completed was splitting the data into a train and test data set. The best method to complete this was the sklearn train test split method. The method easily creates the 4 train and test datasets after inputting the data X and the target Y. Next, we completed some pre-processing by instantiating the count vectorizer and applying it to the data. The count vectorizer method creates a token count array for the data. In order for scikit-learn models and our oversampling method to work, we transform the data from an array to a matrix using the toDense method. Last, we applied oversampling to our training set using the SMOTE method, meaning synthetic minority oversampling technique, from ImbalanceLearn. This was needed because the non-target values dwarf the target values heavily. So after applying the SMOTE method with a 1-to-1 ratio, our target records and non-target records were equivalent in size. Before we built our models for our data, we had to identify a metric to evaluate the models. Accuracy is usually a good starting point, but after identifying the small number of useful votes compared to non-useful votes, accuracy would not have been a good choice. For instance, 5.7% of the data was our target value, and 94.3% was our non-target value. If the model always predicted 0, it would be 94.3% accurate. Therefore, accuracy is not the best metric to evaluate our models. The metric we used to compare and evaluate the models was the F1 score. The F1 score is our harmonic mean between the recall and precision of a confusion matrix. Among the 3 classification models evaluated between the 2 subsets, the random forest classifier performed the best. The Apple subset's F1 score was significantly higher than the Samsung subset score. We believe this is due to the Samsung subset having more overall reviews and fewer target reviews than the Apple subset. Next, we started to refine the random forest classifier by adjusting the hyperparameters. Our group found that Apple required 50 estimations to plateau in performance, while Samsung required 100 estimations. We believe the reason why Samsung required more estimations is because, as in the last slide, Samsung subset having more overall reviews and fewer target reviews than the Apple subset. Next, Chi will discuss our unsupervised learning process along with the LDA analysis.
Thanks, Johnny. This is Chi. I will introduce the methodology of topic modeling. There are 4 aspects: the clean text, apply LDA model, reduce dimensions, and visualize topics. For the clean text part, we use some operators such as tokenize, filter non-alphanumeric, stop word removing, stemming, and filter token length. This is how we apply in Python Notebook. For both Apple and Samsung sub-datasets, we used the same operators. We use tokenize to space text into individual words. We lower the case. Also, we use the isAlpha to filter the words that are not UTF-8 code. Then we filtered the stop words. Use the stemming to transform individual words into its stem, and we set the length of word is more than 1. We append to the text list. We used both Apple and Samsung cleaned datasets separately as their own dictionaries, and this is the example of Apple dataset. Striling will be mapped to the vector by using doc2bow function. Then we applied LDA model separately in both Apple and Samsung corpus. We set 20 as the number of passes. It takes about 5 minutes to generate 8 topics for one dataset. Here is the print of 8 topics by using Apple corpus and in Python notebook. Then Doug will talk about the visualization of the results of the LDA modeling in both Apple corpus and the Samsung corpus.
Thanks. This is Da. After applying LDA model, let's look at the LDA visualization. In this part, we will use intertopic distance map to show the result. The model reduced dimensions to 2 based on PCA, and it applies here. We selected 8 topics to compare the iPhone reviews and Samsung reviews. In the relevance metric, we use lambda to get the best one in our model, so we choose 0.52 to get a better result. In the intertopic distance map, the bigger circle means that the topic is more important. For instance, in Apple reviews part, topic 1 is the most important one. Also, we can indicate that the topic 13 most relevant terms for topic 1. The blue color means the overall term frequency. The red color means the estimate term frequency within the selected topics. In this topic, we can see the topic terms battery, camera, and charge. It actually is about battery life and charging. Next, in Samsung reviews visualization, we use lambda equals 0.155 to adjust the relevance metric, and it applies here. After reviewing the model, we narrowed down the Apple ranked topics, which are battery life and charging, Amazon supplier service, phone accessories, US national carriers, people upgrade from Android, watch accessory comparison with Samsung, user iPhone comparison, and indeterminate. In addition, Samsung ranked topics are battery and camera use, battery issues and charging time, phone warranty and repair, international carrier accessibility, Amazon supply service, customer recommendation and service, Asian market and international market. In conclusion, by comparing Apple reviews and Samsung reviews, we can get that Samsung tends to have battery issues and long charging times. So Samsung is working on the charging and battery problem. Moreover, we can notice that it has bigger presence of international Samsung users compared to Apple. Furthermore, Apple showed more reviews about their accessory than Samsung. The top topic between Apple and Samsung involved battery life, usage, and charging. Overall, our model is meaningful for Amazon users. This is our team members' contributions. If you have any questions, feel free to contact us via Canvas.